All right, this is the AP Classroom FRQ from 6.9. Very classic FRQ, big concept in Calc. Difficult concept, but if we practice it, get used to it, you guys will be prepared when you see this on the exam. So first thing I see here is, without even reading too much, I see this g of x is defined as an integral here. So that's that knee-jerk reaction that I always talk about. So immediately what I'm going to do is I'm going to take the derivative of g of x, and derivative of negative 6 is 0. And then fundamental theorem of calculus part 2, plug the x in for the t. We don't have to worry about the chain rule because the derivative is 1, and g of x ends up equaling just f of x. So this whole graph, which is a graph of f, it's also g prime. So I'd like to write that over there so I know. Sometimes they ask me questions about f, sometimes they ask me questions about g, sometimes they ask me questions about g prime, so having this labeled kind of helps me organize my thoughts. All right, diving right in here, and I put these areas in here already. Is there a value, and I'm thinking right away, IVT, there's no derivative here. Is there a value on this interval that g of x equals 0? So what I want to do is I want to test g of negative 3 first. Let's get a value there. Well, how do I evaluate g? I can't pluck it off the graph because this is g prime. G of x, though, is defined right here. So g of negative 3, so literally g of negative 3 is going to be negative 6 plus negative 3. Well, if x is 3, I plug it in up there. Sorry, negative 3. From negative 3 to 3 of f of t dt. And then, of course, if the lower limit matches the upper limit, we learned from our properties of integrals, that equals 0. So g of negative 3 just equals negative 6. So that's nice. Let me get this out of the way here, just so I can have that standing alone. G of 2. Now, negative 6 plus the integral from negative 3 to 2 of f of t dt. Well, from negative 3 to 2, luckily that's a region that they had defined for us. That's region C. That area is 16. So the net change from negative 3 to 2, that's one of the things the area under the curve gives us. The net change, not in g prime, but in the previous layer, g. The net change is 16, so we gained 16 from negative 3 to 2. Since we knew we had a negative 6 here already, negative 6 plus the net change, g of 2 equals negative 6 plus 16, or positive 10. All right, so that's great. G of negative 3 is less than 0. G of 2 is greater than 0. So that means as long as this function is continuous, the IVT will guarantee that we have at least one value of g of x that it equals 0. Now, as you're writing this up properly to get all the credit, you do need to mention that it's continuous to use the IVT. You do need to mention the IVT, and somewhere in there, I would probably want to write g of negative 3 is less than or equal to 0, is less than or equal to g of 2. Just kind of wraps it up, puts a bow on the box, and I would recommend having that somewhere. All right, next, part B, absolute min, absolute max. Okay, so we need to look at the candidates here. The candidates test is what we're going to ultimately use. So we need to know, where is g prime equal to 0 or undefined? Now, why am I looking at g prime? Anytime you're trying to maximize anything, any function, you look towards its derivative for the critical points. So g's derivative is g prime, this graph, so it will equal 0 at negative 7, negative 5, negative 3, 2, 6, and 9. So almost all of those are our candidates. I am going to omit 6 because the sign of g prime, the derivative, doesn't change. It's negative and then it stays negative, so that's not going to be a relative min or a relative max. So we can cut that one out. Now over here, I wrote those candidates, and so we already had 2 from part A, so that's good to know. So now I need to find the rest. So let's start at negative 7. One thing we could do is, if we're looking for g of negative 7, we can plug it into this formula from negative 3 to negative 7. Now, if we do that, let's just take a look at what that looks like here. Now, this is being pretty literal, pretty robotic. -6 plus -3 to -7 of f of t dt. Well, -3 is greater than -7, so that's a little bit strange. So one method here is you can use that property where we switch the limits of integration and then just negate the integral, so that would turn into a -6 minus the integral from -7 to -3 of f of t dt. And what is that region from -7 to -3? A +5 and a -2. So that's a +3. So I'm really adding 3. So this whole integral is equal to +3. -6 minus 3. That does equal -9. Now that's really confusing, so there's a couple other ways to look at this. Now one, we have positive, negative. We've learned that about our areas under the curve. However, when we are given this setup here, if we're defining g of x with an integral starting at -3, moving to the right, which is the normal direction, the positive direction, that's going to be positive area, negative area. If your lower limit is -3 and you go to the left of that, that's actually going to negate it. That 2 under the curve is actually going to be a +2. That 5 above the curve is going to be a -5. So if we have a value that we know, right here, if we have this value that we know that we were at -6, at g of -3 is -6. Now going backwards, add 2, -6 plus 2 is -4. Subtract 5, you're going to get that same -9 answer. Again, I understand that's a little bit confusing. Another way to look at it too is just start at -7. Let's ignore this whole setup here. You start at -7, moving to the right, gain 5 in area, lose 2. That's gaining 3. And then we knew from previously g of -3, we knew g of -3 was equal to -6. So if I added 3 to a number and the sum was -6, blank plus 3 equals -6, I had to have started at -9. So there's a bunch of different ways of figuring out what the values of g are when you're looking at an accumulation function like this. The way I like to do it, the way I see it, again, the way I see it might not be the way you see it. I do kind of lean on to this format here. So if I'm starting at -3, I just know that going to the left, it's going to be opposite of what we normally do with the up and down. So that's me. So anyways, using that logic, f of -7 is -9. I'm actually going to write that. I'm going to write that over here on the left. That looks a little bit weird, just for organizational purposes. F of -5 now. F of -5. All right, f of -5. So now, if I knew that I was at -9 here, now I'm adding 5. So that's just going to be -4. We already knew we had -10 or -6 and 10. And then f of 9. So I'm going to jump here back to the g of -3 was -6. Add 16, that's +10. Subtract 5, that's 5. Subtract 6, that's -1. So my absolute maximum here, the biggest number I see is right here, f of 2 equals 10. The lowest number I see is here, f of -9. F of -7 is -9. So my absolute max is 10. Now check here, check the question. Are they asking the x value of the absolute max, or are they just asking for the absolute max and absolute min? They want to know, find the absolute min, the absolute max. Those are y values. So the absolute min is -9 and the absolute max is 10. When you're justifying your answer, show the work, show all the candidates. That's going to go a long way. But you also need to reference that you're using the candidates test. All right, so that's a big deal for part B. So buy the candidates test, and then you have all your work nice and organized. All right, C. Okay, this is the easiest part here. This one right here, it's almost seems a little too easy. Might catch you off guard at first glance. The integral of 2x plus 16, that's got nothing to do with that function that we saw up top. So you're just going to take the antiderivative of 2x, that's x squared. That's 2x squared over 2, or just x squared. And then the antiderivative of 16 is 16x. And don't forget, this is an indefinite integral. Don't forget the plus c. And then we move on to this part down here. Now, this is pretty wacky. -7 to 5, okay, fine. F of 2x plus 16. That is really confusing. How am I supposed to take the antiderivative of that? I'm supposed to evaluate it. I mean, I do have a graph of f up here. It's kind of dirty now, but I have a graph of f, but how does the 2x plus 16 factor in? So what you're going to do here is you're going to use u substitution, because if this was just f of x dx or f of u du, f of t dt, this would be a lot easier because then we could use that graph up top. So, and sometimes you might not be sure if what you're doing is going to lead you to where you want to go, but I'm just going to try it and see what happens. Sometimes we just got to get pencil to paper and see what works. So if I let u equal 2x plus 6, then du equals 2 dx. I like to solve for the dx. It just makes it easier on my brain to substitute. So now I have an integral up, not from -7 to -5 anymore. Change the limits of integration. I'll come back to that in a second. F of u, and then dx gets swapped out with dx. Du over 2. And then I'm gonna take that over 2, and I'm just gonna slide that right out in front as a 1/2 out in front. And now the limits of integration. When you're using u substitution, you're changing x's to u's. These limits were defined for x's. I have decided to go to u's, so now I need to get these in their u form. Math is nothing more than just a bunch of substitution. So plug in a -7 for x. 2 times -7 is -14. -14 plus 6 is -8. 2 times -5 is -10. -10 plus 6 is -4. So now I have to evaluate this thing from -8 to 4. I hope I think I multiplied wrong. Oh, because it's 2x plus 16. All right, I'm going to pause this and fix it. All right, so notice that 6 magically turned to a 16. I copied the problem down wrong. That's okay. The derivative of 6 and 16 is both 0, but my limits were off, so let's just redo that. -7 times 2 is -14, plus 16 is +2. 2 times -5 is -10. -10 plus 16 is 6. Now I have just f of u du. That's the graph of f up top from 2 to 6. Hopefully that's a region defined for us. From 2 to 6 is that region D, which has an area of 5. So the area under the curve from 2 to 6 is -5. So that's 1/2 times -5. And you could leave that as the answer. But if we want to simplify it, clean it up a tiny bit, -5/2, and that's the answer to 2. I hope you enjoyed this production of AP Classroom 6.9 FRQ. Have a wonderful night, or day, or morning.